The SARCOS COST Action arose from the need for consolidating a network of researchers working in one of the most current hot topics, such as the development of preventative repair methods, including self-healing approaches, aiming to increase the sustainability of the traditional construction sector and to guarantee the service life of concrete structures. The appearance of cracks in concrete is unavoidable and accelerates the degradation of constructions, diminishing their service life. The development of self-healing approaches that allows concrete healing by itself appears as a highly promising technology for the future. But the incorporation of such technologies in the industry also needs the development of standardized methodologies for the performance assessment. Aiming to solve this, a proposal for a cost action was submitted to COST. What is COST? COST, European Corporation in Science and Technology, is a funding organization for research and innovation networks. The actions help connect research initiatives across Europe and beyond and enable researchers and innovators to grow their ideas in any science and technology field by sharing them with their peers. COST actions are bottom-up networks with a duration of 4 years that boost research, innovation, and careers. The proposal was granted, and the SARCOS CA 15202 COST Action officially started in September 2016. The action focused on the development of efficient self-healing techniques and setting up standardized methods for performance assessment. At the end of it, a total of 28 COST countries had signed the Memorandum of Understanding and thus actively participated in the action. 3 near-neighbor countries had the chance to participate too. The SARCOS COST Action is managed by 2 scientific representatives of each participating COST country. Their contact data can be found in both the COST webpage and also in the specific action webpage. The main decisions were first consulted to the core group, which consisted of the following members. Dr. Mercedes Sanchez Moreno was the main proposer of this action and had been acting as the chair. Professor Nele Di Belli's role was the vice chair. The grant holder institution was the Universitat Politécnica de Valencia in Spain, where Professor Pedro Serna acted as the grant holder scientific representative and Dr. Pepe Bayarri as the grant holder manager. There were 3 working groups. Working Group 1, Self-Healing Concrete and External Healing Repair Methods, led by Professor Nele Di Belli. Working Group 2, Characterization and Monitoring of Crack Healing, led by Professor Liberato Ferrara. Working Group 3, Modeling of Crack Healing and Service Life Prediction, led by Professor Tony Jefferson. Professor Emilia Fidanchevsky was the short-term scientific missions coordinator, and Professor Abir Al-Tabah, the science communication manager. The early career investigations manager was Dr. Marta Rodz Flores, and the inclusiveness target countries manager was Dr. Bojan Miljevic. Complete information about the activities performed during the action period can be found in the action webpage. As a summary, the action management has organized 1 MC meeting per year, in most of the cases co-located with other internal meetings such as core group and working group meetings, and also workshops, such as the first one held in Madrid in 2017. 2 PhD and ECI meetings have taken place during the action period. In both, the young participants of the action could get together and share their experience and problems. The action has organized a total number of 4 training schools, 1 per year. The SARCOS COST Action has granted more than 30 short-term scientific missions, most of them given to young researchers who made a stay in a foreign lab to learn a technique or to perform experiments in collaboration with other research groups. The action has granted 6 applications for early career investigators affiliated to inclusiveness target countries who participated in international conferences on the topic of action. As dissemination, the action has created its own webpage managed by the University of Cambridge, where all the activities and calls have been published. The Action has a profile on Twitter as on Facebook, where news and updates have been posted. As a sample of this network, next you'll find some information about some of the participating research groups. This is Rabanales campus at the University of Córdoba. The multidisciplinary research group of the Inorganic Chemistry Department works from the synthesis of advanced inorganic materials to their application in construction. They study from the most fundamental aspects of chemistry characterization with general instrument techniques to more applied studies requiring more specific instruments. Their research is focused on the development of new technologies and new materials, from the design to the long-term performance assessment. Nowadays, the incorporation of Internet of Things concept in their work by designing and developing wireless multifunction sensing systems for the assessment of concrete performance in real time is a priority. They work closely with the industry, giving answers to specific needs, and are more open to collaborations and customized trials, both at the national and international levels. Welcome to the University of Córdoba. At Universitat Politécnica de Valencia, ICITEC, several members are involved in concrete self-healing and the SARCOS COST Action. Professor Pedro Serna, who participates in the SARCOS COST Action as the grant holder, scientific representative, is the head of the group. These researchers have participated in SARCOS in the production of 2 of the review papers, STSM and Training Schools, and they are leading the interlaboratory test group RRT3, which evaluates the self-healing properties of concrete with crystalline admixtures. ICITEC has a customizable area adaptable for several testing setups, including modules, testing frames and hydraulic presses, a reaction slab and a reaction wall. They also have concrete mixers ranging from 1 to 400 litres. The video shows the production of RRT3 samples. They have worked with other special concrete such as ultra-high performance fibre reinforced concrete, recycled concrete, etc., and have experience analysing several concrete properties. They always work to understand and enjoy concrete. Contact them for more information. Professor Nelly de Belli of the Magnal Laboratory for Concrete Research in Ghent, Belgium, is chairing the Concrete and Environment Group. The main goal of their research is to enhance the durability and sustainability of concrete structures. They focus on concrete with alternative binder materials on the one hand and on self-healing and repair on the other hand. Recently, they also started to investigate whether 3D printing of concrete can result in more sustainable structures. They approach the self-healing by the use of 3 different strategies: superabsorbent polymers, which can absorb a huge amount of fluids and provide them to promote autogenous healing in concrete, encapsulated healing agents, which will be released upon a crack, and bacteria, pre-added into concrete during mixing. They will become active and precipitate calcium carbonate after a crack happens. It's well known that for every ton of ordinary Portland cement produced, around 1 ton of CO2 is emitted into the atmosphere. To reduce cement-related greenhouse gas emissions, part of the cement could be replaced with byproducts from other industries that also have cementitious properties. For example, pozzolanic fly ash from coal-fired electric power plants, pre-treated fine-ground bottom ash from municipal solid waste incineration, processed slags from the steel industry, etc. Concrete compositions with the incorporation of these materials count as potentially green concrete types, on the condition that their durability and service life performance in various environments remain adequate. Also, KU Leuven is taking part in the SARCOS COST Action. Dr. Elke Gruyert is affiliated with the Technology Cluster Construction at the Technology Campus in Ghent. This young research group is focusing on concrete technological and durability aspects. In the context of SARCOS, they're dealing with the mixed design of self-healing concrete and durability assessment of self-healed and repaired concrete structures. The RM4L group at the University of Cambridge is working with self-healing systems for cementitious materials. Their group focus on producing and characterizing systems for autonomous healing in concrete and solid mix materials. They are exploring several ways to produce microcapsules, including membrane emulsification, where a membrane is used to form the emulsions which are then polymerized into capsules. In addition, they use microfluidics, a very controlled way of producing double emulsions, which are then polymerized using a UV light to achieve a core shell structure with control over the size and shell thickness. For healing or larger cracks, they have been working with vascular systems, pumping healing agents such as sodium silicate and quantifying the healing over these structures. To monitor and assess the performance of their healing systems, they have been investigating carbon-based materials to achieve self-sensing by modifying the conductivity of the material. They have explored the implications of their new technologies in infrastructure. Their first commercial trial of their capsule system containing sodium silicate as a healing agent took place in West Cambridge. The capsules were easily added to the mix and then used to produce concrete slabs. They believe self-healing is a step towards a sustainable future with less concrete repair and CO2 emissions. Multidisciplinary team from University of Novi Sad, Faculty of Technology, consists of 3 groups: materials engineering, polymers and microbiology, with a total of 11 researchers. The focus of their collaboration is the development of a sustainable and durable concrete with self-healing ability. It's well known that bacteria can promote self-healing phenomena in the cracks of concrete structures. However, elevated pH value of the cement-based matrix negatively affects the metabolic processes and consequently the self-healing effect. Therefore, to protect the bacteria from its surroundings, they propose using a cutting-edge technology, coaxial electrospinning method, for encapsulating the bacteria healing agent in a polymer hydrogel system. The microstructure and texture analysis, 3-point bending tests, water sorption tests, and crack width change measurements showed the effects of healing on the recovery of performance. Besides these activities, their team regularly perform in situ characterization of materials in cultural heritage objects, enhancing the expertise for their restoration, conservation, and protection. University Centre for Energy Efficient Buildings, UCEEB, was established in 2014 as an independent university institute of Czech Technical University in Prague under the support of EU. UCEEB unites excellent researchers of 4 faculties of CTU in Prague, Faculty of Civil Engineering, Mechanical Engineering, Electrical Engineering, and Biomedical Engineering. The centre's goal is to leverage the synergy effects of research activities of the individual departments which are related to energy-efficient buildings. Researchers participating in SARCOS are simultaneously integrated into the pedagogical and academic staff of Faculty of Civil Engineering. A new scanning electron microscope is available for a better understanding of the inner structure of building materials. The efficiency of new admixtures is studied in terms of rheology properties using modern laboratory techniques. The team is fully equipped for the determination of mechanical properties, advanced analytical methods such as mercury intrusion porosimetry, thermal analysis, or X-ray diffraction. A great contribution to the visibility of obtained results is the organizing of annual conference, special concrete and composites. New composites are evaluated in terms of their durability performance, which corresponds with the main aim of SARCOS. Facing the problems caused by the development of cracks in concrete is addressed by repairs that usually have a significant cost. It's also difficult to estimate the lifetime of the interventions. Developing a product that has the ability to self-heal has many advantages. The mechanism in which the process of self-healing will work depends on the environmental conditions and is often a slow process. The self-healing process is frequent in the composition of lime-based mortars, and the reason is due to the flow of solutions in the structure that dissolve part of the calcite. New materials, devices, and methods of nanotechnology are very promising tools to protect the materials. Nanoparticles could modify the microstructure of materials so that properties such as porosity and strength can be enhanced. Additionally, mineral admixtures have been developed as an approach to the self-treatment of concrete, as they contribute to reducing its permeability. The presence of silicate salts in cement systems seems to play a significant role in the self-healing procedure. The homogeneous distribution of the admixtures and the amount of silicate salts, as well as the time of reaction, are important factors contributing to the healing procedure. Professor Paulina Faria is working in the Civil Engineering Department, Faculty of Science and Technology, Nova University of Lisbon, Portugal, on the durability and eco-efficiency of cement, lime, and clay-based building composites with colleagues from the Chemistry and Environmental Sciences departments. The first self-healing approach for cementitious mortars and concrete is the use of mineral additions, namely artificial pozzolans based on wastes or byproducts. These pozzolans can partially replace the binder with environmental advantages and simultaneously contribute to increase the self-healing capacity of the mortars or concrete. A second strategy consists of using microbial byproducts from different fermentations, some produced from industrial byproducts, to formulate more durable mortars and concretes, or to biotreat the surface of old building materials. Therefore, innovative bioproducts are being developed and tested. The approaches to optimize building composites are followed up with environmental analysis, namely LCA. In Matico is a consolidated research unit of the University of Lyon. Recognized by the regional government of Castile and Leon, dedicated to the study of new materials and manufacturing technologies. The group was founded in 2006. Nowadays it's formed by 3 associate professors, 1 CSIC researcher, 3 assistant lecturers, 1 lab technician, and several PhD, master, and bachelor students. Their research lines are valorization, reuse, and optimization of recycling processes of construction and demolition waste, characterization of recycled aggregates, eco-efficient concrete applications with the replacement of natural aggregates by recycled ones, bio-inspired approaches on construction materials. They put their heart and science to transform waste into valuable resource. Mugla Sidki Koçman University, Department of Civil Engineering, is located in Mugla, which is on the coasts of both Mediterranean and Aegean seas. Laboratory research team includes 1 PhD student and 4 MSc students in the leadership of Assistant Professor Dr. Süleyman Badir Keskin and Assistant Professor Dr. Özlem Kasap Keskin. The self-healing of cementitious composites studied in this laboratory is mainly based on autogenous healing. Besides, the combined effort of several different self-healing technologies is also studied to enhance self-healing performance. To gain a better insight into self-healing behavior, mechanical, transport, and non-destructive tests are conducted. High-performance cementitious composites produced in their laboratory ensure multiple micro-tracking to enable cracks to be filled with self-healing products in the short term. Also, the long-term, self-healing performance of the composites is studied to promote sustainable development through structures with extended service life. The SARCOS COST Action ends with a well-consolidated network of researchers working together in the development of smart construction materials for tomorrow, looking for practical advanced solutions for the end users of the future.